Electronegativity. It's the ability of atoms to attract shared electrons. Noble gases do not have one. The general trend for electronegativity increases up the group and to the right of the periodic table. So this would be the increase in electronegativity. Same thing with the ionization energy and the electron affinity, top to the right. Let's have a look. This should be a cation. So look here with our bromine and then our potassium. The potassium gives up that electron, and that electron here has an attractive pull towards the positively charged nucleus here. The positively charged nucleus here has an attractive force between the shared electrons. This electron here is shared between the bromine and the potassium. Even though it may seem like it belongs to one over the other, it's not true, regardless of if it's an ionic compound, because technically, even if the ionic compound is extremely large, the electronegativity is extremely large, so it's an ionic compound, it does not matter. There is always a sharing effect. It's never just a complete lose or gain of electron based on the principle of the percent ionic character. Then we have our chlorines. We have an electron here and an electron here. The electrons want to go towards this positively charged nucleus. This electron wants to go towards this positively charged nucleus. The positively charges within the nucleus want to attract these electrons that are being shared, as so. Lastly, we have our cesium and our silicon. The neighboring electrons here between them, well, let's say wants to go towards the silicon because the silicon has a positively charged nucleus that wants to attract these electrons. They're quite close to each other. The distance between the two is quite small, so there would be good attraction. But let's look here in a contrasting example with silicon. Now silicon is over here. Fluorine, very, very small. Look at the distance between the two. It's extremely small because fluorine is such a small atom. So the neighboring electrons here definitely have an easier time going towards it. So fluorine has a very high electronegativity because of its atomic radii. As you can see, it follows a trend. As the atomic radii is smaller, the nucleus will exhibit higher electronegativity. The nucleus is so close to the valence electron of the other atom. This is why it's able to exhibit such a high electronegativity.